Hi there. Today I will share with you how to find the confidence interval of the proportion. So you can go to the code file and go down to see you go to the tab here. You see confidence interval for proportion. You click on here. It will take you to the formula that you have right here. So you can copy the whole thing and then you can find the answer, but I'm gonna walk you through what does this mean in here. Okay, so let's see this question over here. So suppose that the insurance company randomly survey 659 driver and found out that 534 claim that they always buckle up. So construct the 85% confidence interval for the fraction of all the driver who buckle up here. So that what we're going to do, we're going to enter order here. So I have the p hat right here, that means sample proportion. So in this case, they give us the how many drivers right here, right? So that I will have, that would be my n, would be equal to 659. And then I have the x as how many people buckle up. So that would be equal to 534. Yeah. And then so my p hat over here, I'm going to do over here, I will write that here p hat. P8 only, so because I'm going to use the code here, it have the P8, so I'm going to copy that. So it equal to the how many people buckle up with the x, and then I divide it by how many people total I survey. So that would be my p hat. So when you evaluate this one, you will get the answer, give it to you, right? So I'm gonna copy this here. I'm gonna paste to the part. Yes, I have that. And the alpha over here, so I have that would be 85%, right? So that would be the alpha. I'm gonna type over here because I need that for value later. So alpha equal to 85%. You can do in your head 1 minus 85%, I mean 100% minus 85%, or you just type in here, let this one deal with it, okay? 1 minus 85, I mean 0.85, it do this for you. It's something small like 99 you can do, but something some of you may have trouble with this one, just type in that, it do it for you. So when you hit the evaluate, it will give you the number right here, that would be 0.85. You have it right here, yeah. Okay, and then the z alpha over 2, that would be the critical value right here. So you have two things right here. So remember that we do that part, it's going to have the lower and the upper. So they're going to be these two numbers. So we're going to copy this one, we're going to put it in. But in order to do that, we have to do this one here. That q, that means that the when you have the formula in there, that will have the complement of the proportion. So that's what your q equal to. Q equal to 1 minus p8. So you have that one. Q equal, yeah. So when you have this one done right here, so you're gonna copy this code right here. So they're gonna give you two things. So you're gonna use the Q2 only. So I'm gonna copy these two anyway and do this. So when you copy over here, you put this. So you hit evaluate, it's gonna give you the last value right here. Yeah. So evaluate, it's gonna give you that last value you have here. And the other one, if you do value, if I remove this one, I remove this, and then evaluate, it's gonna give me the other value, the negative one. So I'm gonna put it back. So this is what we're gonna need right here, okay? And we're gonna call for later, okay? So this will be the number that I'm gonna paste to the critical value right here, alpha over 2, that I have that. So keep that in mind. This value here, you see the formula here, it depends on alpha only. It doesn't depend, this is not depend on the sample value, yeah. And then from that, you're going to find the margin of error right here. So again, this formula you get from the textbook. And then I just type in here so that make you save for you some typing time. But there is no mystery on this number at all. So I evaluate this one. I should have the critical value right here. That be the margin. I'm sorry, this is margin of error that I have in here. Right, so I'm going to copy this value. Yeah. And then I'm going to put it in here. That would be my margin of error. Now the confidence interval, that would be equal to the p hat right here, and then you minus with margin of error. That for the lower bound, and the upper bound would be ph and then plus margin of error. So you're going to put it in here. So I'm going to have lower bound equal to, so I have here p8, and then I might margin of error, and then I evaluate. So this is what I have for the lower percentage I have here. Yeah. So we have this one, and then the upper, that would be, you add to that one. So upper bound, right, will be equal to p8, and then you plus margin of error, right? So you have that, you evaluate. So you have your value right here. You put in here, and you'll have that. So we are 85% confident that the fraction of drivers who always buckle up in between the here will be around like 79% up to 83%, rounded up, if you can say that one. I submit here, I should have all answer correct. And so that's how you do the part here. Oops, the alpha over here, I do something wrong. It should be a 15 instead. That one I subtract, so I should have that 15 instead. Submit it again, so I have all correct right here. Yeah. So I hope it helped, and go down to the link below, get the question practice again.